Chinnaman, and I was responsible for the electrical hardware system of the project.
My name is Samuel Jacobs. I am the Chief Structural Engineer on the Zeebo project.
My name is Michael Vartan, and I primarily worked on the computer systems on Zeebo.
My name is Stephen Lee, and I was responsible for the acoustic modem system.
So let's get started here.
And I'm going to talk to you about the Zeebo structure. The robot itself consists of an aluminum hull with an exoskeleton surrounding it. The hull is a 12-inch long aluminum tube, a 1/4 inch in diameter, with a 10-inch outer diameter and 9.75-inch inner diameter. On each end of the hull, there's a 13-inch outer diameter flange. Each flange has a clear acrylic cover. A silicon gasket goes between the cover and the flange. Inside the hull is our electronics payload. The exoskeleton itself is made of 80-20 aluminum building material. The 6 thrusters are mounted directly to the 80-20 aluminum.
Propulsion system consists of 6 Seabotics thrusters, each of which have a max voltage rating of 19.1 volts and a max current rating of 4.6 amps. To control these, I developed custom driver boards that use a built-in integrated H-bridge driver and controller. They have a max voltage rating of 24 volts and control current up to 12 amp. They have an integrated current sensor which allows us to maintain a max 19 volt output to the thrusters themselves as to not damage them. These thruster driver boards get their power from two 22.1 volt 5000 milliamp lithium polymer batteries. We chose these batteries due to their high power density factor and because they are lightweight compared to other batteries of relative size.
The primary computer on Zeebo has an i7 core running Ubuntu. We chose the Node JavaScript language because we wanted Zeebo to run on an event-based platform. As an autonomous robot, Zeebo is primarily going to be responding to events. It's responding to pingers going off, it's responding to distances, and most of all, it's responding to objects in its vision, which we've implemented using USB cameras and OpenCV.
The Vision subsystem incorporates 2 webcams that have been potted in resin. One located on the front of the vehicle facing forward. The second camera is facing directly below the vehicle.
The Zeebo robot at its current state is 54.2 pounds in air. It is neutrally buoyant in pool water, that is fresh water, and it is slightly positively buoyant in salt water. The maximum height of Zeebo is 23 5/8 inches. The maximum width is 27 5/8 inches. The maximum length is 32 1/2 inch.
Controls are sent over UART to the primary peripheral board. The primary peripheral board runs on an LPC 1768, which is an ARM chip which was created for low-power small applications such as our peripheral boards. One of the things we considered when designing Zeebo was how we were going to simultaneously control so many motors. Traditionally, you'd use the on-chip pulse width modulation to control motors. Because chips typically have limited PWM pins, we decided to manually implement PWM using timers. Every time the timer interrupt is handled, it toggles the pins which need to be toggled, and then calculate how long it should wait until the next time pins need to switch. This allows us to efficiently control our motors without using more chips dedicated to pulse width modulation.
A custom board was created to mount this IMU-2 Zeebo. This board will be located outside of Zeebo's waterproof hull to reduce the amount of electrical interference with the magnetometer.
I will discuss the boards implemented in this design, the receive RX and transmit TX board, utilizing the LPC 1768 microcontroller. Digital representation of each state of the control system of the submarine will be converted to an audio signal centered at a reference voltage of positive 3.3 volts. My first iteration utilized pulse width modulation to transmit the signal to an 8 ohm 3 watt speaker in the 100 Hz to 20 kHz frequency range. It will sample binary data on 2 digital data pins. These data pins have internal hold-down resistor configuration and are logic 1 when voltage is greater than 2 volts and logic 0 for voltage less than 0.8 volts.
If I was getting paid for this, I'd do it the first try.